Hey boys and girls, this is lesson 5.3, all about adding fractions. Please get that written in your notebook as well as today's date, and when you're ready, come on back for the lesson. Okay, so the first thing I want to start with is this math message. So I want you to draw a picture in your notebook to help you solve this number story I'm about to give you, all right? So here's the story. Matthew ate 1/3 of a small peach tart. Scotty ate 1/3 of another peach tart that was the same size. Together, how much peach tart did they eat? Okay, so after you've drawn the pictures to try and help yourself solve that, write an equation to show how much peach tart the boys ate together. Give that a try in your notebook, and then when you think you have it, come on back. Alright, so hopefully you would have told me, well, they ate 2/3 of a small peach tart. You would have hopefully drawn a picture of a peach tart and another peach tart, and you can make that peace sign. Ooh, not so great, but I'm trying. And you would say that Matthew ate this one and Scotty ate this one. So together they ate 1/3 plus 1/3, 1/3 plus 1/3 equals 2/3. Hopefully that's what you would see there. Okay. So in the last problem, would you say Scotty and Matthew ate more than or less than or exactly a whole peach tart? So think about what you said the answer was there. And hopefully you got it's less than. 2/3 of a small peach tart is less than one whole small peach tart. Okay? If I put those both within the same, let's draw that for you here real quick. If I did the two peach tart pieces, so this is Matthew's and this is Scotty's, you can see that there's still 1/3 that's left. So that's less than this whole, right? Okay, so how about this problem then? Matthew ate 1/3 of a small peach tart. Scotty ate 1/3 of a large peach tart. Together, did the boys eat 2/3 of a peach tart in this number story too? Why or why not? Write your thoughts on that in your notebook, and when you think you have it, come on back. Okay, hopefully you'll say no, that they wouldn't have eaten 2/3 of a peach tart. And on the why not, in the first problem, hopefully you could say that both boys ate a fraction of a small tart. The whole was the same, a small tart for each one of them. So when adding those fractions or those parts that refer to the same whole, you just join them or combine those fractions. But in the second problem, the one above, one tart is small and one is large, and they don't refer, therefore, to that same whole, so they can't just be combined. I couldn't put two pieces that aren't the same size together and make them the same size, right? So that's something I just want you to keep in the back of your mind. The problems that we're going to work on together today are going to have the same whole, and we could say we'll be working with like denominators. The denominators, the bottoms of the fractions, will be the same. Okay? So what I told you at the end of the previous slide is just to make sure you understand that, but that's not the kind of problem we're going to work on. So here comes the problem for you. So Cassie's teacher assigned 12 math problems for homework. Cassie finished 3/12 of the problems at school. She solved 2/12 right when she got home from school. What fraction of the problems has she solved so far? So as you start thinking about this problem, some questions you might want to ask yourself. What's the whole? That's always a good way to start a fraction number story. What's the whole? And does each of the fractions in this problem refer to the same whole? Are they talking about the same whole for both of those fractions? Think about that, jot some quick notes, and then come back. Hopefully you would say yes, that they refer to the same whole, and you could do this kind of a whole number box here. that lists what the whole is, and that's 12 math problems. All right? So here's some strategies you might use to solve this problem. There are a lot of them, so I'm going to go over them with you. If you came up with yet another strategy to solve that problem, that's great, and we might talk about yet another strategy when we're together in class. But let's talk through some of these strategies, okay? You could use fraction names. So just as you know 3 hats plus 2 hats equals 5 hats, the same would be true if I said 3/12 plus 2/12 equals 5/12. The unit is twelfths, so I only really have to worry about the numerators in that situation because I'm using the denominator as my unit. So think that through for a second, if that makes sense to you, how I could just change the thinking of those fractions to having the twelfths be the unit name. Then I just combine them. All right. Another way, second bullet point down here, is I could think about 3/12 as the sum of unit fractions. Remember those from 5.1? So 3/12 is the same as 1/12 plus 1/12 plus 1/12, and 2/12 would be the sum of 1/12 plus 1/12. So if I put all of these together, this is what this would look like, right? And when I add those together, I'm going to see that it's, yes, indeed, 5/12. So I could write it like this. That should make sense to you, because we did talk about unit fractions. I could use a number line poster. That's what this is going to show you over here, a number line poster. Each part or interval on the 12th number line represents 1/12 of the entire distance. And I could place my finger on 3/12 and then use another finger to count up 1/12 and 2/12 and saying out loud, so I'm 3/12, now I'm at 4/12, and I'm at 5/12. So that I could do that method, and that would get me to my answer of 5/12. Or I could even use fraction circles. So the red circle can be used to represent the 12 math problems, or the whole. And then I've got these 2 that were done at home and these 3 that were done at school. So altogether I have 5 out of the total of 12. 5/12, right? Okay. So those are some strategies you could use. I'm going to give you another problem, and I'm going to have the same kind of conversation with you. So after running 3/4 of a mile, Mrs. Kelly stopped for a drink of water. Then she ran another 3/4 of a mile. How far did she run in all? Some basic questions first. What's the whole? I showed you a whole box there, so you should be filling that out. Does each of the fractions refer to the same whole? And do you think your answer will be more or less than 1 mile? So a couple things to think through. Jot yourself some notes. Come back and check that out. So hopefully you get that 1 mile would be the whole, because I'm talking about 3/4 of a mile. That's 3/4 of 1 mile. 1 mile is the whole. The fractions are referring to the same thing because they're both 3/4 of a mile here and here, 3/4 of a mile, so yes. And I think it's going to be more than 1 mile because 3/4 is only a fourth away, and this is 3/4 more, so I think I'm going to be more. So again, how could I solve this problem? So I could do what we said the first time. I could use fraction names, just as 3 dogs plus 3 dogs equals 6 dogs. I could say 3/4 plus 3/4 equals 6/4. The unit I'm doing is fourths. I could have said dogs, right? But I need to know that if I'm using fractions, I can just put it in words and use that word of the denominator as my unit. That works. I could again do some of the unit fractions. So I've got 3/1/4 plus 3 of the 1/4 all together. That's going to give me 6/4. And that's how I could simplify that equation, right? I could use the number line poster. I'm starting at 3/4 and I'm going to go up 1/4 more, 2/4 more, 3/4 more, which is going to land me at the 6/4. I could use fraction circles. The red circle can be used for the 1 mile. So I did 1, 2, 3 before I got a drink, and then 1, 2, 3 after, which is going to give me 1, 2, 3, 4, 5, 6 of these fourths. And I can see that by looking at this model that would be 1 and 2 fourths. I can change my improper fraction into a mixed number of 1 and 2 fourths. These are equivalent, 6 fourths and 1 and 2 fourths. All right, so there's several strategies you can use. Pick one that works for you and take a look at the problems on page 159. Use any of those strategies or more than one of those strategies, totally up to you, but choose what makes the most sense to you. Once you've done them, come back and check out the answers and correct your page and pen so that I can see what you might need more help on when we go over them at the lesson. All right, I hope you have a fabulous night.